Chapter 7, Problem Decomposition. This chapter covers understanding problem decomposition and why we need to do it. Using top-down design to carry out problem decomposition and write programs. Writing a spelling suggestions program using top-down design. In Chapter 3, we talked about why we shouldn't ask Copilot to solve big problems. Imagine what could happen if we asked Copilot to design a two-player strategy game. In the worst case, Copilot wouldn't do anything useful. We observe this sometimes when Copilot gives us comments again and again, but never provides us with real code. In the best case, we'd get a canned program with all the decisions made for us. That program may not match what we wanted. Part of the power of being a programmer is customizing what we're creating. Even if we didn't want to customize anything, what would we do if the program from Copilot had flaws? It would be difficult for us to fix a large program that we don't understand. For us to get a program that does what we want, we need to feed small subproblems to Copilot and assemble those solutions into our own program. The focus of this chapter is learning how to break large problems into smaller subproblems, which is essential to being able to solve the large problems we want to solve. Section 7.1. Problem Decomposition. Problem decomposition involves starting with a large problem that may not be fully specified and breaking it down into subproblems, each of which is well-defined and useful for solving our overall problem. Our goal is then to write a function to solve each of those subproblems. We may be able to do this for some subproblems with a reasonable amount of code, but other subproblems may still be too big for us to capture in a function of reasonable size. In Chapter 3, we mentioned that we want to keep functions short, something like 12 to 20 lines, to give us the best chance of getting good code from Copilot, testing that code, and fixing bugs in that code if necessary. If a subproblem is still too large to be implemented in a single function, then we further divide that subproblem into sub-subproblems of their own. Hopefully, each of those sub-subproblems will be small enough now, but if not, we'll continue dividing those too. The key reason we do this is to manage complexity. Each function should be simple enough so that we can understand its purpose and so that Copilot can solve it well. If something does go wrong, we won't have too much code to trawl through to find the problem. When we write code that is extremely complex, we're likely to make mistakes. The same goes for Copilot. And when we have mistakes in long, complex code, they aren't easy to find and fix. It's hard to overstate the importance of problem decomposition for quality code. The process of starting with a large problem and breaking it down is called problem decomposition. The way we're doing this here is synonymous with the software engineering technique known as top-down design. It's called top-down design because we're starting with the large task we want to complete and breaking it down into smaller tasks. Once we've completed the top-down design, we can implement the resulting functions in code. We'll have one function for our overall problem, which will call the functions for each of our subproblems. Each of those subproblem functions will further call their own functions, as needed, to solve any of their sub-subproblems, and so on. As we discussed in Chapter 3, we're looking to end up with functions that each have a small role to play in our overall program, and whose behavior is clearly defined. We need those functions so that we can call them to reduce the complexity of functions that would otherwise be too complex. To improve clarity and ease of understanding, we seek to design functions that have a small number of parameters and return a small amount of highly useful information.